Hello everyone, welcome to the next part of Microprocessor and Microcontroller module, where we have discussed already about 8086. Now today's topic is about the pin configuration of 8051 microcontroller. So how it works? Let's get started into the video. In the first part, we have to know how many ports are there in 8051. There are already 40 pins present in 8051, like in 8086 also. But what are the pin configuration? Let's start. The 8051 microcontroller features four 8-bit input-output ports. What are the four 8-bit ports? Port 0, 1, 2 and 3. Total of 32 input-output pins available for interfacing. So let's get the discussion about this port. Port 0 means dual functionality, acts as input-output and also serves as multiplex address data bus for external memory. Port 1 means it is a dedicated input-output port which is equipped for internal pull-up register and it is commonly used for general purpose input-output application. Port 2 means it is also a dual functionality port and also acts as input-output port. Serves as the higher byte of the address bar for external memory. The last one is the port 3, P3. It is also the dual functionality, acts as input-output ports, supports special functions such as interrupt, serial communication and timers. And practical example of this input output ports is the interfacing with sensor, display and communication device with real world application of 8051 microcontroller. Clear? So these are the input output ports in 8051. Moving to the next slide is the instruction set of 8051. So what are the instruction set? Instruction set memorize that first part is arithmetic instruction which purpose is perform basic mathematical operation. And what are the key operation of mathematical? Addition, subtraction, multiplication, division as we all know. Examples are ADD that is add two values, SUBV that is subtraction, MUL that is multiplies, DIV that is divides. Next one is a logical instruction whose purpose is to perform bitwise operation. What are the key operation? AND, OR gate, XOR gate, NOT gate. Examples we all know about AND gate, OR gate, XOR gate and NOT gate. Next one is a data transfer instruction whose purpose is to move data between registers, memory and external memory. And the examples are MOV that is move A, move X, PUSH and POP that is push and pop. Push and pop means full form is push data onto the stack and pop means pop data from the stack. Clear? Next one is the branching instruction. Its purpose is to control program flow. And the key operations are jumps, calls, returns. Examples are JZ label, call, ADDR and RET. Full form is jump if zero flag is set and call ADDR means call a subroutine at a specified address. And RET means return from a subroutine. We all know from the name. Next one is a bit manipulation instruction. Its work is about set, clear and test individual bits. What are the examples? ACTB bit that is set a specific bit, CLR bit that is clear a specific bit, JB bit jump if a specific bit is set, and CPL bit that is complement a specific bit. Clear? So this is for the second slide. Moving to the next part is interfacing with external devices. As we all know from the last video, interfacing means the connection of this microprocessor or microcontroller with the external device. So how interfacing works in this case, let's get to know. Types of external devices commonly interfaced: LEDs, switches, LCDs, motors and sensors. These are the things we have to interface with the interfacing. Second one is the LED interfacing. That is connecting LEDs to input output ports via current limiting resistors. How to implement this? We have to use the port to control LED status. How to implement use of ports to control LED status? An example circuit is simple circuit diagram showing LED connection to a port pin. Next one is the switch interfacing, which connects switches to input output pins with pull up and pull down register. How to implement? It helps in reading switch states to detect input. We have to also make circuit diagram illustrating the switch connection. Next one is LCD interfacing. This is very interesting. It uses 4-bit or 8-bit mode to connect LCD to input-output ports. It sends commands and data to display information. Next one is motor interfacing. It also uses transistors or motor drivers to control motors via input-output pins. It implements PWM, there is a pulse width modulation. We all know about this, that is to vary the speed of the gadget. It also needs circuit diagram and sample code to run. Next one is the sensor interfacing. Sensor interfacing means it helps in connect analog sensors via ADC, that is analog to digital converter, or digital directly to input output ports. It helps in reading sensor data for processing, like in all cases. So is it clear now? Moving to the next slide is the addressing mode of 8051. This is very important topic in your syllabus. 8051, what is the addressing mode? The operand is a constant value specified directly in the instruction. And what are the example? Move A, that is load the value 25H into the accumulator. A means accumulator. And also it loads constants or initial values directly into the registers. So what are the types of addressing mode? First type is immediate addressing mode. And we already discussed about this immediate addressing mode. Next one is register addressing mode. In the definition, we have to write that operand is located in a register. In register addressing mode, the operator is located in the register. Example A, B, RO to R7. Example move A, that is move accumulator RO, moves the content of register RO into the accumulator. Third one is direct addressing mode. In direct addressing mode, the operand is specified by an 8-bit address in the instruction. Example is move A 40H, that is load the content of memory location 40H into the accumulator. Clear? All the examples are clear. Now to the next slide. Addressing mode of 8051. Addressing mode of to understand addressing modes, we have to determine how to the microcontroller access data and instruction efficient data access is crucial for optimizing performance in embedded system. The 8051 microcontroller supports several addressing modes, each with unique characteristics. Clear? Type of addressing modes: immediate addressing mode, register addressing mode, and direct addressing mode. Now the next part is register indirect addressing mode. So what are these? Register indirect addressing mode. Discuss how different addressing modes are utilized in programming the 8051 microcontroller. Clear? And indeed indexed addressing mode means the operand address is calculated using a base address, that is DPTR or PC, and an offset. What are the example? Move C A, that is loads data from program memory using DPTR as the base and A as the offset. And what are the case? Accessing lookup tables or data stored in program memory. And the previous one is the indirect addressing mode. We have already know about this. So up to this, I think it's clear. So next video, we will all discuss about the next part. Thank you.